Although you may not be familiar with the term the triboelectric effect or triboelectricity, you're actually very familiar with the effect itself. It's what happens when you have wool socks and you have a carpet and you rub your wool socks up against the carpet and you touch that doorknob. That spark comes from the triboelectric effect. So the first thing you might be asking is, where did that electricity come from when my finger touched the doorknob? It turns out that whenever you rub two dissimilar materials together, that there is a charge exchange between them. One side will become more positively charged, and the other side will become more negatively charged. For example, whenever you take a balloon and you rub it in your hair, electrons from your hair are actually put onto the balloon. This makes your hair net positively charged and the balloon net negatively charged. This is why your hair sticks to the balloon when you pull it away, because the positive charge and the negative charge are always attracted to each other. So your hair, being positively charged, is attracted to the balloon, which is negatively charged. This is also how a Van de Graaff generator works. As the belt of the Van de Graaff rubs against the bottom wheel, charge is exchanged between that wheel and the belt. The charge is then moved along with the belt, up the belt, and up to the large metal sphere where the charge is stored. But this effect appears elsewhere too. If you take 3M Scotch tape and peel off pieces of it inside of a dark bathroom, or in this case, done inside of a vacuum, as demonstrated by Seth Putterman and Carlos Camara at UCLA in 2008, you'll see a blue light appear. That's because as you pull the tape apart, charges are exchanged between the sticky surface and the non-sticky surface of the tape. So one becomes positively charged and the other one becomes negatively charged. The electrons from the negatively charged part will move back through the air to the net positively charged part, and when they do, they create a spark and a plasma, and that's the blue light that you see. Now, it actually turns out that the triboelectric effect, this effect of charge exchange, has been known for centuries. There are some practical applications of the triboelectric effect. For example, old accelerators and some still modern ones actually used Van de Graaff machines to generate that potential so you could move these charged particles through at really fantastic speeds. People are also investigating it for other applications, like generating X-rays for X-ray machines, or generating power for, say, microphones or something like that. Although there are many things that we do understand about the triboelectric effect, there are actually lots of things we don't. It still remains quite a mystery. For example, we can't really know exactly what causes the charge exchange between the two surfaces. We don't know how to measure whether one surface is going to be positive to another or negative. We don't really understand what those mechanisms are. So there's a lot of neat, cool things that remain unknown about the triboelectric effect. So although this phenomenon has been known for centuries, we still don't know actually a lot about that. And sometimes that's the exciting part about science. That's the exciting part of doing science, is that you find out these common experiences sometimes we have, like rubbing your socks against carpet and getting a spark, is a physical phenomenon that we still don't truly understand. Thank you so much for watching this video. I hope everyone has a wonderful rest of their day and week, and I will see you later. If you like this content, please like and subscribe for more of it, and I'll be seeing everyone later. Thank you. Bye-bye. This has been a video from Van Cleef Scientific. If you like this, please like and subscribe for more content.